So in order to do the cooling fluid lubrication, the cooling system will cost $171. The fueling system will be $173. Lubrication $156. The weights for the cooling system are 11 pounds. The fueling system 16 pounds. The lubrication 6 pounds. The total cost will be $500, and total weight will be 32 pounds. And now I'll turn it over to Shri Prajapati, who's in charge of the exhaust system.
Hello everybody, my name is Sridhar Prajapati. I'm in charge of exhaust system for 2009 FSA. Here is the goal, as we have discussed in the PDR. We are going to lower the weight of the exhaust system, maximize the scavenging effect, and tune the system from between 5,000 to 9,000 RPM. And we have to comply with the sound limit of 110 decibels. These are our basic goals for the exhaust system. And here is the Ricardo wave analyzed model. And as we are seeing the primaries over here, and these are the crossover pipes. Here is the secondary, and here are the collectors. These are the primary collectors, this is the final collectors, and this is the muffler right here. This is the chart comparison between the 2009 and engine speed versus scavenging efficiency with crossover pipes and without crossover pipes. As we are seeing, our main RPM range is between 5,000 to 9,000 RPM, and between those RPM with the crossover pipes we are getting the maximum scavenging efficiency over here, while without crossover pipes we are getting the very low scavenging efficiency. So we are going with the crossover pipes with this, and here is the comparison between engine speed and scavenging efficiency of 2008 versus 2009. Here in the 2009 we are a little bit higher in the scavenging efficiency compared to last year, because we have adjusted the cam timings, which the cam was advanced 2 degrees positive to the intake and 1 degree retarded to the intake manifold. That's why we are getting the little bit higher scavenging efficiency this year, which is very desirable. And here's the analysis for the sound system. As we are using the same muffler as the previous year, we are getting 108 decibel at 11,000 RPMs, which is under control. And here we are going to manufacture the exhaust system. Tube bending will be outsourced, muffler flange and the exhaust port flanges will be manufactured in-house on the CNC machines, and the welding method will be outsourced. Here are the sources for the materials and the services for the exhaust systems. Supra alloys for the tubing and titanium sheets, bond steel for the collector manufacturing, and the Repair Tech International for the titanium welding. And here is the cost for this year, which will be $850 for exhaust systems. And here is the summary for the exhaust system, which primaries will be 15 inches long, crossover pipes will be 4 inches away from the collector, the primary collectors, and the primary tube diameter, outer diameter will be 1.5 inches, intermediate pipe length will be 6 inches, and intermediate pipe length, pipe diameter or secondary body will be 1.75 inches, and tail pipe length will be 9 inches, and final diameter will be 2 inches, which will connect with the muffler, and the muffler will be 20 inches long this year. And here is the comparison of weight, as we have reduced 9.30% weight reduction this year because of we have used the whole titanium, and compared to last year they have used the primaries with the stainless steel. So we are gaining the advantage of the titanium this year, and we are reducing the 9.30% weight this year. And here is my friend Fabian Martinez, which will introduce for the drivetrain. Thank you very much.
Hello everyone, my name is Fabian Martinez. I'm in charge of the drivetrain system. To begin our slides for the drivetrain, let's take a look at the design specifications. Maximum tractive force is 450 pounds. Maximum linear acceleration is 1 g. Our engine operating range is from 4,000 to 1,200 RPMs, and our design variables is the differential system and the final drive ratio. For the design result for the drivetrain this year, it will be a rear sprocket, which it has 38 tooth, front sprocket 10 tooth, and the final ratio will be 3.8, and the torque bias ratio for the differential is 2.6 after it has been braked in. Now let's take a look at one of the main components and their analysis for the drivetrain, which is the bearing bracket support. It is manufactured out of 6061 aluminum. For the design analysis, we use a static loading, which consists of a 3,110 pounds on the X direction, which it will be towards the front of the car, 890 pounds force on the Z direction, which is up to the car, and our result is a factor of safety of 1.9. And for the fatigue analysis, we choose to decide to use 100,000 cycles with a factor of safety of 1.03. Our front sprocket is manufactured out of 4340 steel. It has 10 tooth, which 4 of them are restrained. And for the analysis, we use a 370 pound force. For the static factor of safety, we have a 2.1. And for the fatigue, we decide to use 10 million cycles, and it gives you a factor of safety of 1.03. Now let us see the rear sprocket. Is manufactured out of 7075 T6 aluminum. It has 38 tooth, which 16 of them are restricted. And for analysis, we use a 913 pounds bearing loads. And for the static load, we have a factor of safety of 1.9. And for the fatigue factor of safety, we have 1.06. For the hub shaft, we're going to reuse previous optimized design because it has been proven to be reliable. And for the tensioning system, it will be a tensioning differential. The main components are the bearing bracket, which is right here, the rear sprocket, front sprocket, and the chain. It has been proven to be reliable. Now let's see the weight distribution. As we can see, the major weight on the drivetrain is concentrated in the differential assembly, the jack shafts, and the stop axles. The total weight for this year, it will be 26.59 pounds. The total cost for the drivetrain will be $1,349. And that brings us to the summary of the powertrain presentation.
Okay, so to summarize the powertrain, an overview. I have the maximum wheel horsepower will be 70 horsepower. The maximum wheel torque will be 40 foot-pounds. We will use an aluminum log-style intake manifold. A full titanium exhaust system will be used, and we will use a lightened steel differential housing. So here's the various weights of our system. We have the exhaust at 10 pounds, the intake at 4 pounds, the fueling, cooling, lubrication at 33 pounds, the drivetrain 27, the engine 130, and the total weight for our department will be 204 pounds, and that's a weight savings of 3 pounds versus last year. So our costs, our exhaust will be $850, our intake $250, the cams will be $250, the oiling, cooling and fueling will be $500, the drivetrain $1,349, the engine will be $630, and the total cost will be $3,829, which is a significant reduction over last year. And so now I will turn it over to Mario Miranda, who's in charge of the chassis department.